Scientists have recently discovered that gravity can create light, which is an entirely new phenomenon that has never been observed before. During the early universe was incredibly small and dense, and all matter and energy were concentrated in one place. Inflation is a theoretical process that is thought to have occurred within the first moments of the universe's existence, causing a rapid and exponential expansion of space. The universe grew from a subatomic size to the size of a grapefruit in a fraction of a second. This rapid expansion caused the universe to cool rapidly, leading to the formation of the first subatomic particles. The inflationary theory was proposed to explain the uniformity of the cosmic microwave background radiation, which is the afterglow of the Big Bang that can be detected throughout the universe. Parametric resonance is a physical concept that we can observe in our everyday lives. Have you ever sat on a swing and tried to go higher by pumping your legs back and forth? When you match the resonant frequency of the swing, you are able to transfer energy to the system, making the swing go higher. This is an example of parametric resonance. In the early universe, an exotic form of parametric resonance may have occurred, leading to the creation of radiation. The intense shaking of space-time caused by waves of gravity could have created standing wave patterns where the gravitational waves weren't traveling, but the waves stood still, almost frozen in place throughout the cosmos. Since gravitational waves are literally waves of gravity, the places where the waves are the strongest represent an exceptional amount of gravitational energy. As a result, the regions of intense gravity may have excited the electromagnetic field existing in the early universe at that time enough to release some of its energy in the form of radiation, creating light. This gives rise to an entirely new phenomenon, the production of light from gravity alone. While there is no situation in the present-day universe that could allow this process to happen, it shows that the early universe was a far stranger place than we could possibly imagine. Gravitational waves are a result of the distortion of spacetime caused by the motion of massive objects. The motion of these objects creates ripples or waves that travel through space at the speed of light. These waves are very weak and difficult to detect, which is why it was a significant breakthrough when scientists first detected them in 2015. In the early universe, when the cosmos was still in its infancy, gravitational waves might have been much stronger. During the period of inflation, the universe expanded rapidly, and gravitational waves would have been generated as the universe stretched and contracted. These waves might have become very strong, and they may have even created standing wave patterns where the waves were frozen in place. This means that the gravitational waves were not traveling but instead stood still, almost frozen in place throughout the cosmos. Since gravitational waves are waves of gravity, the places where the waves were the strongest represent an exceptional amount of gravitational energy. The study of gravitational waves can tell us a lot about the universe, including the nature of black holes, the behavior of matter in extreme conditions, and the evolution of the cosmos. The detection of gravitational waves has opened up a new field of astronomy, known as gravitational wave astronomy, and it is expected to lead to many more discoveries in the future. Standing wave patterns occur when waves with the same frequency and amplitude interfere with each other in such a way that they seem to be standing still. This happens when a wave traveling in one direction meets another wave traveling in the opposite direction. The two waves interfere constructively, creating regions of maximum amplitude called antinodes and regions of zero amplitude called nodes. In the early universe, researchers have suggested that standing wave patterns might have been created by the intense gravitational waves that were present during inflation. These standing wave patterns would have represented regions of exceptional gravitational energy, where the gravitational waves were frozen in place. This is because the gravitational waves, which are ripples in spacetime, were so strong that they caused spacetime to oscillate at their frequency. These standing wave patterns could have had significant effects on the electromagnetic field existing at that time, which may have led to the creation of radiation. The researchers found that the standing wave patterns of gravitational waves could have excited the electromagnetic field in the early universe, leading to the release of energy in the form of radiation. This process may have created light, which is a groundbreaking discovery. We can say that the intense gravity of the standing wave patterns of gravitational waves could have caused a disturbance in the electromagnetic field present in the early universe. This disturbance could have resulted in the excitation of the electromagnetic field, causing it to release energy in the form of radiation. This radiation may have included the creation of light, which is something that we have never observed before. This discovery challenges our current understanding of the relationship between gravity and electromagnetic fields and raises many questions about the early universe that we have yet to answer. The production of light from gravity alone is a new concept that challenges our current understanding of the universe. In the early universe, regions of intense gravity may have excited the electromagnetic field enough to release some of its energy in the form of radiation or light. This phenomenon could have been caused by the standing wave patterns that were created when strong gravitational waves shook the early universe. The strength of these waves represented an exceptional amount of gravitational energy, which may have excited the electromagnetic field, leading to the production of light. However, in the present-day universe, there is no situation where this process can occur, making the early universe a far stranger and unique place than we can imagine. The discovery of the potential for the production of light from gravity alone challenges our current understanding of the early universe and the laws of physics that govern it. It suggests that the universe was not as simple and uniform as we previously believed, and that there were complex interactions between different fundamental forces at play. This discovery also raises many questions that cosmologists and physicists will need to answer, such as how these intense gravitational waves could have been generated in the early universe and what their impact might have been on other fundamental forces. Furthermore, it may have implications for our understanding of the origins of dark matter and dark energy, two mysterious phenomena that make up the majority of the universe's mass and energy. The discovery that gravity can create light is a groundbreaking one that challenges our understanding of the universe. This discovery may lead to many more discoveries and may change the way we approach cosmology in the future. We hope that you found this video informative and that you learned something new today. Thank you for watching, and don't forget to subscribe to our channel for more exciting videos about the wonders of the universe.